Hello and welcome back to the Building HVAC Science podcast. This podcast aims to help create better, more knowledgeable HVAC and building performance pros. And we hope to achieve this by helping the two professions better understand each other, with the ultimate goal of having our listeners help create better environments for all people. Today's episode, Eric and I get to speak with Berlin Raj. He helps us unpack this idea, this concept of a single box hydronic monoblock system that combines space conditioning, domestic hot water, pool heating, thermal and lithium storage, EV charging integration, and backup power. Now, this is born from Berlin's lifelong tinkering with the idea, stop wasting condenser heat, capture it for hot water while cooling. So the system keeps all the refrigerants sealed in the outdoor unit and runs packs to supply and return indoor air handlers, ducted or ductless, avoiding all the complications and intricacies of refrigeration piping setup and line runs. There's a lot of interesting aspects to this product, including load matching from 1.5 to 6 tons, dynamic load limiting for small panels, even 20 and 30 amp circuits, and modular thermal storage up to like 100 kilowatts cooling or 55 kilowatts of heating, as well as a 10.5 kilowatt hour lithium battery pack. And those were kilowatt hours before what I said just a second ago. This is a product that's engineered for residential and light commercial use. The unit can supply hot water up to 165 degrees, support radiant underfloor heating at lower outdoor temperatures, and operate down to about -8 degrees Fahrenheit, and can be manifolded for capacity and redundancy. So this is a product that's coming out soon, and in full disclosure, I'm one of the advisors to Totex, but I think it's important for everyone to hear, to comment on, and to have visibility about this product. There's a couple of neat quotes Berlin mentions in the podcast interview. Why dump condenser heat when you can use it, cool the house, and make hot water at the same time? As well as people. Comfort is ultimately about humans first. There's some links in the show notes to Berlin's LinkedIn profile, the Totex website, and you can come visit Berlin in person. He'll be presenting at the U.S. Heat Pump Summit in November of 2025. Okay, let's get into this interview with Eric and I speaking with Berlin Raj about hydronics, storage, in a single box. Berlin Raj, Totex Vision.
Hey folks, welcome back to the Building HVAC Science Podcast. Eric Kaiser over here. Mr. Bill Spohn, the great Overkill Bill, right over there. And our special guest today, we got a pretty cool special guest. This is an exciting one for me and for Bill, I think, because we've been talking about this for a little while. Berlin Raj from Totex, and Berlin is actually kind of from the future because he's in Australia and he's about 14 hours ahead of us, I think.
Yeah, something like that.
Yeah, something like 14 hours ahead of us. So he's from the future. It's tomorrow right now when we're talking to him, which is blowing my mind. I've already asked him how tomorrow is. I don't know. How is tomorrow, Berlin?
Hi, thank you. Tomorrow is so fantastic. The coffee tastes so much better in tomorrow. Things are much nicer. Raining a little bit, but yeah, when you get to tomorrow, there won't be rain. It'll be fine.
Berlin, I've known you for a few months now, and I'm basically helping you advise the company. So full story be told, if anybody can use that to interpret what they want about things. But here, I think you got something really cool going on. And I think the really cool thing, and I think you explained at length before we started, a little bit more about your backstory and childhood. And I'll just say, I did the same thing. I used to take things apart and occasionally put them back together. So I want to hear a little bit about the childhood tinkerer, Berlin Raj.
Growing up, I grew up in India. My childhood is quite interesting. I couldn't learn things by memorizing. I'm very super interested in how things work. So I'm always pulling things apart to see how things work. If you bought a TV or washing machine or something at my home, the next time my parents go away, I will open things apart, see how things work, and try put it back. Often it doesn't work, so I'll be in a big trouble. Soon I learn how to fix stuff. So I've been fixing this stuff for my family, friends, all of these people. Something like tinkering, always tinkering. I got electrocuted like over 100, like maybe 1,000 plus times.
Sometimes you learn and sometimes it takes a while, apparently.
Yeah, that's right. Yeah. One of the interesting thing on the tinkering part is like, we didn't grow up with air conditioner. At summer, it can get very hot. Our homes are built with masonry blocks and concrete. There's no insulation. That means it takes all the heat. It's a big thermal mass. Even though the outside air is like cools down at night, it's still very, very hot in the night. So I've been like walk around the home with a thermometer and see we had a pond in front of our home. How can I use the cool water to cool the home? How can I use the cold air outside to cool the home? Putting ventilation fans, stuff like that.
So you started in HVAC a lot of years ago then is what you're saying.
That's right. Yeah, lots of years ago. It was very hot, uncomfortable childhood sleeping days. So
You told us a little while ago that you worked on some projects in remote areas of India. Can you give us some information on that?
as soon as I started, throughout my growing up, I had like so many different gigs, like doing electrical wiring for homes, sprinklers for farms, things like that. So I couldn't wait to finish my engineering to start a business. So once I finished my engineering, we set up a company to help hospitals in India with their power systems. So in India, often like over 12 hours in a week, there won't be power. That means we are running these expensive generators. These hospitals were spending so much money on diesel fuel. So we were helping them with their power systems. We'll add in rightly sized generators, turn off one generator, turn on the smaller generator to meet the demand. This is all across India. So in most of these projects, the biggest headache we had came from heating and cooling again and hot water. The 70% of the demand goes for this, and we've been spending so much money on it. That's how I worked on a system that can reduce the cost of energy. One of these hospital projects, we proposed Totex system. I said, okay, I can build this thing. We can put a Totex system. This is the system. The name was not Totex. So the director of the hospital asked us, okay, you are a design and build contractor. You're not a Mitsubishi or Daikin. How are you going to build this one, sir?
So apparently you like challenges.
Yeah, I like this. Yes.
Totex is kind of an idea you had, or was this a couple people that had this idea to put this whole thing together?
I had this idea. The main idea I had is when we cool the indoor space, most of the time in India, many parts of the world, like the high cooling demand. So when you cool the space, the outside unit is heating the air outside, and that heat is wasted. I'm like, how can we use that heat to heat the water? Because we're spending more energy on heating the water. That's how the idea came out. Then I had some fantastic people coming on board to helping me bring it to life. Because I'm not a software engineer. So now we have a software engineers in house. The idea is getting better and better. Now the system can do heating, cooling, hot water, pool heating, EV charging, and backup power, all of that in one.
You've also won a few awards, some pretty notable ones. Can you share those?
Got a few of those awards.
Some contests and programs and things.
Yeah, we got nominated actually for a couple of these awards. We got nominated for the Best Newcomer Award for the Australian Startup Ecosystem. We didn't win that award. We went to the top 4. We also got nominated for the Best Climate Tech Startup in Australia, the newcomer range. Within last 2 years, what is the best startup coming on board? We also got nominated for that one. We didn't won that one yet, but we'll win that one the next year maybe.
What's the current status and the plans going forward?
We developed the system now. It's a couple of pilots are running in Australia, and we like to move to Texas. So I'm planning to move to Texas.
That's a little ways away.
That's right. Yeah, I was in Texas last year. Then I'm going to Texas next week, and we plan to move to Texas early next year. Texas will be ideal location for Totex.
And is that why there's Tex in the name of the company?
That's right. That's a good thing, isn't it? Totex.
Yeah, totally Texas.
That's right. That's right. Yeah. The literal meaning of Totex is total expense.
Total expense. Okay.
We want Totex to be lowest total expense by year 3. And we want Totex to be lowest total emission. It also means totality. So it's a single system, does all the things. Yeah, that's why the name. Now we said Totex, so okay, Texas can be there. We add Texas.
Let's dive into what is Totex, because I'm pretty sure that a lot of people listening to this right now are going, wait a minute, what? Who is this? We've never heard of this before. So give us a quick overview of what the Totex system. Now, it's an HVAC system, but it does a lot of other things that you just mentioned in there as well.
Totex system is a single box. It's a main outdoor unit that sits outside that does heating, cooling, hot water. You connect your hot water to it, heats the water. And it also have a battery inside. So that means we can keep provide backup power to the home. This all comes in a single box, sits outside, and then inside the home you have the air handlers. It can be ducted unit or split systems, ductless unit. It's all connected through hydronic PEX pipes.
You're just literally running PEX pipes outside, connecting those up to the outdoor unit. That outdoor unit is already built in the factory. You plug the PEX pipes in it, and you're ready to go.
Yeah, that's right. Yeah. In today, all the hydronic systems is a more complex. You need multiple valves outside, multiple circulator pumps outside. We reduce a lot of that in our designs. So now connect the PEX pipe main unit to the indoor unit. Chilled water plus glycol solution comes in to cool the space, and hot water comes in to heat the indoor space. The entire refrigerant stays within the main unit. That means we don't need the system comes with pre-charged. Don't need to vacuum it on the site. There's no high pressure mechanical joints to worry about a refrigerant leak.
I'll say that's a big change from what we're used to in the US. This is what's called a monoblock system, and it's a bit different. So do you have to do one indoor unit with this from like a blower perspective, or can you do multiple indoor units?
We can have multiple indoor units. It can take 2 air handlers if you need to, or single larger air handler, or even wall units. So we can have a ductless wall units on each room, and all the pipes that connecting can be daisy chain. That means you run two main one supply, one return. Each of these indoor units can be branched from that. At the moment, the multi-split systems, each indoor unit need 2 copper pipes and power wiring. In Totex, we can like daisy chain, like branch out from the main supply and return.
Very nice. That's definitely something that's a little different than I think a lot of us are used to in the United States from an HVAC perspective, is a system that gets hooked up like that. Unless you're in large commercial places, then we talk about chilled water and heated water and things like that. But in the residential space, and this is really targeting the residential space, correct?
Yeah, residential and small businesses like a McDonald's, like KFCs, and small offices. Yeah.
Yeah. So residential, light commercial. That's cool. You said we were talking a little bit ahead of time on this, and we're talking about heating water as well as cooling simultaneously. And you told us that this will heat water while it's cooling the indoors. So you're taking that heat out of the indoors, dropping it directly into the hot water rather than dumping that heat outdoors and having to use another device to heat the water, correct?
That's right.
What sort of efficiency savings? Because to me, that it changes the way things are rated efficiency wise. It changes the way the unit operates efficiency wise because we're not having to do those 2 separate steps. What does that do to the electrical consumption overall?
Yeah, so electrical based on how much shower you get. So my wife, for example, I take 30 minutes, 40-minute shower. Taking shower is my thinking time. That means we save a lot of money with Totex. The COP wise, our test units have a COP of over 9 plus. That because we are like capturing both sides of the heating cycle. All the air conditioners, we're using one side of the heating cycle and let go of the other ones. The hot side is wasted when we cool the space. Because we're capturing that, then the entire half of the portion of that is captured. So COP is over 9. We can also use this heat to heat the pool if we need to.
Yeah, so if you have a pool at the house.
Yeah, all of that is free energy. It's all hydronically looped, so we are not playing with the refrigerant. We're not sending refrigerant to long distances. There's no oil segregation. There's a lot of advantages with this.
Why do you think no one's done this before? Or have they done it in ways like this?
They have done it before. Bosch have heat pumps, hydronic heat pumps that can do heating, cooling, and hot water. One main issue is like a very expensive system, and the installation is very complex. Many of the systems we look at that they need entire like 6 by 8 foot wall. The entire wall is having all these pipes, fittings, pumps, air leasing valves, all these different things. So we avoid a lot of things with the new design. Some modifications to heat exchanger. With Totex, it'll be like installation will be very similar to traditional systems. Connecting the main indoor unit and the main unit are connected to just 2 pipes.
So you want it simple enough that the young Berlin would understand it when he took the lid off.
That's right, yeah. So we don't want complexity. As we add more and more parts, there's more things that can fail. And then there's a very small, at the moment, the Bosch heat pumps that can do heating, cooling, hot water, water to water, they're like very expensive. It costs like over $60,000. And we are like lowering the cost so it can compete with the normal air conditioner, still have all these advantages.
Now, did we get into detail in why Texas?
Few different things about Texas. They have heating demand, cooling demand, and hot water demand. All of them there. In many northern parts of US, there's a larger heating demand. and rarely need cooling. The Totex, the benefit is much higher when you have all of them, when you have more cooling demand. For example, in Texas, there's like over 7 months of cooling period. That means we can provide free hot water. Because we are even though it's like very hot outside, because we are cooling our home, we need to have hot shower. That means we can provide free hot water like over 7 months. In Florida, for example, over 10 months of cooling period is there or dehumidification needed. So during that time, we can provide free hot water, almost year-round free hot water. That's one main reason for Texas. And Texas houses are larger; they're using more energy, and it's more privatized market, so we can launch in Texas much easier. The Texas state alone is twice as big as in the market size wise, twice as big as Australia. A lot of advantages to be in Texas. We'll still keep Australia going. We have our team here, but I'll be moving to Texas to focus on US market.
You'll be in the U.S. a lot this year because you're also going to be at the Heat Pump Summit.
Yes, I'm talking, speaking in the US Heat Pump Summit. In November, I'll be meeting you in person. I'll be meeting Eric in person as well.
Yes. And anyone else who's listening who's going to that summit, look it up, usheatpumpsummit.com. Quite a cast of speakers there, about 40 or so. A lot of different topics. Lots going on there.
Yeah, it'll be very interesting. They're bringing a lot of installers. Several installers will be there. So many interesting topics on new technologies, making the installation better, making the customers' experience better. So many different ones. Eric is speaking on something, right?
Yeah, I'll be talking with Mr. Bryn Cooksey, good friend of mine from up in the Detroit area, about different types of heat pumps, different types of controls, and how they operate. It's called Winter Peaks and Control Freaks. And Bryn and I are both very passionate about putting these heat pumps in right, because right now, a lot of them don't get put in well, and they don't really get set up well. And that's an interesting point, which comes back to Totex. And I'm curious, what kind of controls are you going to have on all this? Is there just going to be using conventional 24-volt thermostat, or will it be communicating controls? What sort are you going to do?
We're using a 10-inch touchscreen controller. So it'd be a Totex touchscreen controller and mobile app control. Touchscreen and the mobile app control will be our control. Yeah. It doesn't work with other thermostat now. It comes with our own thermostat, and the thermostat and the main unit is connected through a Modbus wire and a 24-volt, powered by 24-volt from the main unit. Communication is Modbus. And it has Wi-Fi, Bluetooth, and all other bells and whistles.
And Modbus is a very solid communication system, in my opinion. So I'm glad to hear that.
Yeah. And the reason we're having Modbus is then we can integrate with many other control systems as well. You can go into BMS. If someone already has a BMS, you can even connect with people who use like a Home Assist. If they want to control the entire system, we can integrate with different ones.
Very cool. So how much energy, you mentioned battery energy storage. Does it also do thermal energy storage? And how much can it really store as far as energy-wise, both electrical and I think you said earlier it does thermal as well, correct?
Yeah, that's right. The energy storage is built with both thermal and electric. 70% of the demand on a building is thermal. So it makes, at the moment, what we're doing is we buy energy as AC power, changing that to DC, then DC to not thermochemical, like into chemical batteries. Then when we convert it back to AC power, we're losing around 15% on it. It's more expensive process. So what we're doing is there's a smaller lithium battery inside the system, 10.5 kilowatt hour of lithium battery, and larger thermal battery. The thermal battery has a capacity over 100 kilowatt hour on the cooling side and 55 kilowatt hour on the heating side. It's a hybrid between thermal energy storage and lithium energy storage.
So the lithium energy storage would then run the compressor or whatever else to extract that thermal heat from the thermal storage? Is that how that would work? Or
that's a good question. The lithium is running only there's a circulator pumps there to move the thermal energy storage medium to the energy storage to the indoor unit. When there is peak pricing, the evening times when the energy price is super expensive, we're not running the compressor. We not just run this circulator pumps to provide. It uses the thermal energy to cool or heat the indoor space. And the lithium battery can also power the everything else in the home, like lights and computer and cooking, all the different things. It's essentially a Tesla Powerwall comes within the system. A Tesla Powerwall has 13.5 kilowatt hour of energy storage, Totex at 10.5. And the heating and cooling on a home fully depends on the Tesla Powerwall. In Totex system, the heating and cooling is depending on the thermal energy storage, mostly. Once the thermal energy storage ran down, then we can use the lithium to run the compressor to heat and cool the space as well.
So there's a lot of data management to make all these decisions about where to put the energy, where to take and put the energy. Is that something that the system knows how to do or learns how to do?
It knows a little bit and continuously learns. The way it learns is like some people, they'll be like, no one will be at home during the daytime. They'll be using energy only at evening. Then we see the patterns of how things going. Also based on weather. So we can understand where is the weather is going the next 5 days. Then we know how much energy we are going to consume tomorrow and the following days. Then we can choose how much energy we need to buy and store. We can optimize. Or we can say, okay, Saturday, I'm going to use the pool, bring the pool to 30 degrees.
By a certain time of day.
Yeah. Then we know, okay, how to operate to reach that temperature.
And for those of you listening in the US, he said 30 degrees. That's Celsius. That's really warm for a pool.
Well, it could be an ice plunge.
That'll be fun, isn't it?
Yeah.
That's going to be a hard ice plunge right there.
It is hard.
At 30 degrees.
That's right. Yeah. So that is like 86 degree Fahrenheit. Yes. One of our customers, his wife won't go into the pool if it is less than 90 degrees.
Wow.
Yeah. So like 31. So like close to 90 degrees.
I think the American Red Cross says 82 or 84 is the max for swimming without suffering.
It's almost a sauna. So
yeah.
But that is a very good highlight of differences in personal preference, because some people want that a little bit more heat because their body is different, and thermal comfort is very, very personal.
That's right. Agree.
Can you walk through the install process? So we'll move ahead to next year, 18 months from now. Contractor has a customer that wants one installed. Not the buying process so much, but the installation process. They're going to receive like how many components on a pallet and what are they going to need to do step by step?
On the installation wise, the main components are like 4 main components. One is the main unit that sits outside, and then the air handler unit that goes in, and there's a water tank. It'll be just like a normal water tank, 100 gallons water tank for the hot water, and the thermal energy storage module. So it's all modular. That means we can choose to have the thermal energy storage module or not to have the thermal energy storage module. We can choose to have the main unit and the indoor unit connected to PEX pipe. At the moment, we are connecting a liquid line and a gas line to copper pipes. With Totex, it will be a PEX pipe. It will be a 1-inch PEX pipe connecting the main unit to the indoor unit. And the installation process is very similar to traditional system, but there's no copper flaring. There's no mechanical joints. It's easy to connect PEX pipe.
Gotcha. And then they're going to have to put some glycol solution in that PEX pipe.
Yeah, loading it, charging it, there's a charge. Yeah.
There's a charging point to fill in the glycol solution on it. The system comes with already a refrigerant charged in it, so we don't need to do the refrigerant charging.
And that's a contained loop.
Yeah, contained loop, closed loop. And the PEX pipe, it can be like a easy to connect, like a shock pipe fittings type. So that means the installation will be much easier. And the pressure is half the pressure as a tap pressure. So any pipe bursting, risk on pipe bursting, and leaks are very, very less.
Yeah, because it's a closed loop, so you're not going to have an endless amount of water coming out of it either, right?
Yeah.
Is there a amperage range? What's the power consumption? Watts?
So the 30 ampere, 240 voltage. Yeah.
So 30 amp circuit.
The 30 amp circuits. The compressor is modulating. That means we can run it like very, very less. It can run for 1.5 tons to 6 tons. It can vary up and down. 6 tons on the cooling capacity, 7 tons on the heating capacity. So we can load match.
But then with the ability to load match on the glycol side, you're not really going to run that. Just because a compressor's running doesn't mean you got to have 1.5 tons of cooling on the water side, correct?
That's right. Yeah.
So you can modulate that water side down even lower than 1.5 tons.
Yeah, it can match exactly of what is the indoor requirement is. On the amperage side, we also have a tech called like dynamic load balancing. So that means if someone has a limited power capacity, we can match their maximum. We can run the system so that we are not consuming more than their allowed capacity. So we can set the main circuit breaker on the home, like let's say it's a 50 ampere. If there's a lot of cooking and other loads are happening, there's only like 15 ampere is available. Totex will only consume that 15 ampere to make sure the main panel load doesn't go above 50.
That's interesting.
This could be a good solution then for somebody that wants to go to a heat pump, but doesn't necessarily have a 200 amp panel. They might be able to easily run this off of a 100 amp panel because you don't have to have the HVAC unit plus a water heater plus all the other stuff running simultaneously.
That's right. Sometimes you need to do all the cable upgrades and stuff, which costs so much money. We have a pilot customer who's running a 20 ampere circuit. So the system never go above 20 amps. It's just maintains there. With the lithium battery inside, we can also dispatch energy. So we never increase that demand, increase the rating of the main circuit breaker while providing all other loads. Let's say induction cooktops can be like 7 kilowatts. That itself can take like 30 amps. So we can send some energy from the system to power the induction cooktop and other things.
You can do load or electricity sharing back with the grid in the house if you've got a smart system in there to measure that power draw. Is there any integration with solar or I think you mentioned electric vehicle charging as well?
Yeah. There is a system talks that if someone already have a battery in their home, like a Tesla and any other battery, we talk with the batteries. If someone doesn't have a battery, only have solar, we still monitor how much solar is generating. Based on that, we can store that energy. In many parts of the world, when we send our solar to the grid, we don't get much money. We get like a 1 cent, 2 cents, something like that. So we monitor how much solar is generating. Instead of sending to the grid for 1 cent, 2 cents, we store it as thermal energy, then use that for heating, cooling, and hot water. At evening and night, it's essentially work as a battery. Another cool thing is we are adding a passive heating cooling mode. That means it only uses your excess solar to heat or cool the space. It doesn't consume from the grid.
It's got a lot of very interesting and varied features on it that could be really flexible for a lot of installations and a lot of options.
You've laid out the business, your background, the product. You've teased us with some appearances. You're going to be in the US a couple times in the next couple months. What can they expect next? What's the timing? And be considerate because sometimes with startups,
That's right.
weird roadblocks get in the way. So what are the general timeframes of what's going to happen next with Totex?
Next with Totex, I'm moving to Texas early next year, and we'll be deploying some pilot projects now. We have some pilot customers who are coming on board. Mid next year and mid to end of next year, the product will be available for anyone to buy. At the moment, anyone who wants to join as a pilot customer who has a pool in their home, they want to heat or they want to electrify their homes, it'll be very fun to have them on board.
So what's the best way for someone to either learn more or get a hold of you to learn more?
They can send an email from our website, like a Berlin at totexenergy.com. They can connect with me on LinkedIn. We'll be happy to talk to them. Installers, customers, anyone who's interested to know more about Totex.
And Bill, of course, is going to link all this in the show notes, I'm sure.
Yes, absolutely. Yep.
Thanks, Bill.
Just in case anybody wants to know. He's good at that.
So when I went to Bill's home, right? So when I went to Bill's home, I looking, okay, can we put a Totex here? But he already have a good system. So
Eric Kaiser's twisting my arm a little bit.
Oh, yeah.
He's saying I should get one.
Yeah, you should.
I think you ought to put one in.
Yeah, that's right. You also experiment a lot of things. You have a Raspberry Pis at home. You have the EV chargers there. You install all these things. Yeah.
True.
If you want a home to play with, Bill's got just about everything you could possibly want to play with. He's got solar. He's got an EV. He's got a lot of stuff.
Energy monitoring.
Yeah, energy monitoring, a zone system.
Yeah, next time when I come, I will hire a excavator so we can dig a pool.
As long as the pool's big enough for Billy's dog, that's okay. That size pool.
Okay.
So I got a couple questions here. These are a little more technical. How hot can we get water with this? Like for floor heating or for heating for hot water? Where can we go with this?
The temperature is like 75 degrees max on the hot water side. That is 165 degree Fahrenheit. That's the maximum for hot water.
That's pretty good hot water.
Yeah. But when we heat the indoor space, we are not sending that much temperature. We're not sending 160 degrees. So we send the minimum temperature to meet the demand. That means, let's say, we're just turning on the system, we might send it at like 160 degrees to heat the indoor space. Once the indoor heating is reached, we probably send it around like 105 degrees, 110 degrees to increase the efficiency of the system to meet the demand. It goes very up and down.
Yeah, it's going to vary a lot depending on what it actually needs to make the system run long, but also heat the space at a comfortable temperature. And I think that's a difference that we see in using a hydronic system versus a refrigerant based system. That hydronic system is going to have a lot more variable capability in it.
With the hydronic, you can now have underfloor heating as well. In a single system, you have underfloor heating and the cooling. With underfloor heating, we can supply a temperature 85 degrees Celsius, still have a very comfortable warm home. The efficiency will be much higher.
What is the lowest outdoor temperature that you can operate this in? Because this is another thing that we see in the States. Like, we get some pretty cold weather here. And depending on where it's at, of course, geographically, we've got a wide range of winter temperatures that we try to operate in.
We tested the system out to minus 22 degrees Celsius.
So that's a minus 7.6 Fahrenheit.
That's right. Thanks for the calculations. Yeah.
I got a converter right here in front of me. I'm looking at it.
Continuously operating at that temperature. And the system is like the compressor, we are using a heavy duty, like a cold weather rated compressor. So we have a high, we call it as a difference between low and the high can be like over like 65 degrees Celsius, 70 degrees Celsius. And it can run at that.
So the differential can be up to 70 degrees Celsius.
Run continuously at 70 degrees. It can go 80, 85 and still run continuously. So the compressor is a heavy duty rotary compressor, very hard to kill. The system we have, two of the pilots we are running is we continuously running at 120% speed, overclock 20% higher, and it's still going for 2 years now.
Yeah, so I think that's going to be two big questions that a lot of people are probably going to want to know about this. So that's why I wanted to throw them out there and get that out there, because those are questions I hear a lot from people in the United States.
Yeah, cold climate heat pumps. You'll hear that at the heat pump summit too. I'm sure that'll be a phrase you hear a lot about.
It can work with other boilers. For example, as a hybrid system, you can connect a boiler along. So you don't need to, if it's a home is like very large, you don't need to have sizes very, very large. You can still add gas boilers if you need to.
So what if somebody, say, you mentioned houses here, big houses. What if somebody wanted to have multiple of these units? Can you actually tandem, hook two or three of them together onto a single hydronic system if they need more capacity?
Yeah, it can. 2 or 3 units can sit together outside the main unit. They all can share the load. One other advantage is redundancy. So if one system doesn't work, you have the other 2 systems to keep the home hot or cold. Added benefit of redundancy.
Yeah, a little bit of redundancy in there, a little bit of flexibility. Interesting.
Yeah, that's a one big advantage. In other traditional system, you can like a VRFs and stuff, like you still, if one system leaks, even though you can connect 2 of them together, like one leaks, the entire refrigerant goes out. There's a lot of issues with like a oil return and things. Those are avoided.
Let's just say one of these units is installed in somebody's house. It breaks down to the point where it can't be replaced at the outdoor unit. How long would it take to replace that outdoor unit? Unhook the existing one, drop a new one in there, hook it all up, and have it back up and running.
Yeah, no refrigerant charge is needed. Pull them out, put a new unit.
Yeah, so you don't have to do the vacuum, no refrigerant charging. You're just basically unhooking PEX pipe and hooking PEX pipe back up, electrical, probably control wiring, and maybe draining the glycol out of that system and putting it back in. Is that a couple-hour job maybe?
Yeah, like a 3 hours job. If it's just a drop in, drop out, it's like only less than 3 hours job. And there's a waste strainer, so you need to check the waste strainer to make sure the waste strainer is not blocked. Glycol doesn't need to be replaced. It's the same as our car's radiator, right? So car goes through like extreme work conditions. So the glycol doesn't need to be replaced. The waste strainer need to be checked to make sure it's not clogged. And then pull that out, put a new unit in. One other thing why the system comes with a battery is like a Tesla Powerwall, for example, the cost of the system is, the equipment is like $6,000 to $7,000. But once we install it, the cost is $14,000 to $18,000. It varies. Like it's over $7,000 goes on install and all these things. Basically, have the battery inside the system, the cost can go down. There's no separate battery installation. So everything comes in, drop in, you get the battery, you get the heating, cooling, hot water, all of them comes as a single package. We're talking with so many installers, getting all the feedbacks to make the installation process as easy as possible.
That's great to hear.
We're going to put some links in the show notes, and I'm pretty sure we're going to have you back here at some point when you got some new level of achievement going on. But in the meantime, what's a closing thought you like to leave with our listeners?
Yeah, people. So everything is about people. That's what I will say. Even though we are in the business or doing whatever different things, all about people. We keeping people comfortable, using people. If you focus on people, everyone's life will be much better from a people's perspective.
That is a great closing thought. Thank you.
I like that a lot. Focus on people. You're right. That's amazing.
Super. Well, thank you, Berlin, for spending some time with us today. Tomorrow, sorry, what is it?
Yeah, the future. Yeah.
Future. Guy from the future. And he says it's okay. So we're going to trust him. We look forward to seeing you in a couple months at the Heat Pump Summit.
Yes. Thank you so much, Bill and Eric.
All right.
Thank you.
Thanks for listening to this episode of the Building HVAC Science Podcast. You can leave a message on our voicemail on our podcast page, buildinghvacscience.com. There's a little microphone in the lower right-hand corner. And we encourage comments and feedback no matter what platform you hopefully enjoy our content on and whatever medium you choose to reach us in. You can also drop us an email at marketing@truetechtools.com. That's TRUTECHTOOLS.com. Some of the topics we discuss require technical training for proper interpretation or safe execution. So if you're a trained pro, you can proceed immediately. If you're not, please consult with a pro and hire one. The Building HVAC Science Podcast is a production of TrueTech Tools Limited. Full disclosure, I am the owner of TrueTech. The opinions expressed are those of my guests, my co-host, or myself, depending on who is speaking. And in this episode, I am also an advisor to Totex, to Berlin's company. If you're in the market for tools or test instruments mentioned in the podcast, look at what TrueTech Tools has to offer. You can use the offer code HVACBS for a nice discount. I want to thank you for listening to and hopefully enjoying and following Building HVAC Science. Until next time, take care.